So good day everyone. So today we'll be dealing with electricity generally. So we know electricity is the flow of electric charges. So what are charges? Charges are what are ions, you understand? Now let's forget about that. That is not the major point of today. So today we'll be dealing with electricity, and we have two forms of electricity. We have the first one to be electrostatics. From the word static, it means something that is stagnant, that's something that is not moving. So when we say electro, so we mean electricity that is what statics. You understand? And the second one is what is current electricity. And you know current is what is the flow of charges, right? So when you say flow of charges as current, it means this type of electricity we have to do with what moving, right? So that is it. So the current electricity charges will be moving from one point to another. So today we'll be dealing with electrostatics. We are going to be focusing on the electrostatic part before we move to current electricity, maybe in the next video. So dealing with electrostatics, I already defined what electrostatic is. So we'll be starting with the first part, which is very important. And what is the first part? The first part is what is on the electric force, because we'll be dealing with electric force, which this man Coulomb defined. The relationship between the electric force and the charges of substance. Then put it that way, we get. So from that part now, we'll be dealing with what Coulomb's law. Coulomb's law is trying to show the relationship between the electric force, the two charges, let's say charges 1 and charges 2, maybe in terms of maybe when you are dealing with A-level stuff, you might have something to do with charges 1, 2, 3, something like that. You have situation like that. But for you to understand that, you are going to be dealing with two charges only. So Coulomb showed the relationship between electric force and two charges. Charges 1, Q1, charges 2, Q2, and the distance between them. If they are at a certain point from each other, there's going to be a certain distance between them. So Coulomb is trying to show the relationship between this particular force and the two charges with the distance between them. So now the man states that what the electric force, we have the electric force what is directly proportional. When you say something is directly proportional, that is F is directly proportional to what? To the man say the product of Q1 times what? Q2, and inversely to the what? To the square of the distance. So let me put it this way. So we have what? F is directly proportional to what? Q1 times what? Q2 over what? R squared. So we're gonna say F is directly proportional to what? Q1 Q2 over R squared. So I don't think me multiplying Q1 times Q2 should be a problem for you. So can you see F equals to what? Is directly proportional to what? Q1 Q2 over what? Over R squared. So now you know how you write your proportional constant now. When you have something like this, let's say we have F is directly proportional to N. So we can say F equal to Kn, right? So you know how to do the stuff like that. So with that now, that is now where we are going. So we can say F equal to K Q1 Q2 over R squared. So that is the first part. So we are showing the relationship between the two charges Q1, Q2, and the what? And the distance between them. So the man is trying to say that what? The electric force is directly proportional to the product of Q1 and Q2, and inversely proportional to the what? To the square of that distance. So that is the first part of what? Of Coulomb's law. So from this part now, we are going to be dealing with what it is, what the F means. So F means what? The force, electric force, and the unit is Newton. Then the next part is what? Is your K. Your K is what? Is the electric what? Constant. And the electric constant K equals to 9 times 10 raised to power what? 9. Okay, so from this part now, you can now deduce that the unit will be what? Newton meter square over Coulomb what? Square. That is, if I make K the solid formula, I can have K equal to FR square over Q1 Q2. So it's very small here, so you might not see, but you are going to get it equal to force is what? Newton. R is what? Meter square over Q1 Q2 is what? Is Coulomb square. So that's equal to Newton meter square per Coulomb square. That is the unit of what? Of the K, you get. But the value is what? 9 times 10 per what? 9. The magnitude is 9 times 10 per what? 9. So that is the first step to what? To electrostatics. Picking from electric field intensity now, let us move to electric field intensity. So electric field intensity is also known as electric field strength. So from this formula, let's say this formula, F equal to mg. So here now, this is what? This is gravitational force. We call it gravitational force. and this is your mass, this is your acceleration due to gravity. So here now, this one is what is the gravitational field intensity or the gravitational field strength. In this situation now, we have in electric field now we have F equal to Q times your what, your E. So this one is what is your electric field intensity or your electric field strength. This one is your what gravitational field intensity or gravitational field strength. This is your mass when we are dealing with gravitational field, because in gravitational field we are concerned about mass. In electric field we are concerned about what, charges. So they are very similar. This one is gravitational force, this one is electric force. This one is your mass, this one your what, your charges, and this is your what, gravitational field intensity or the gravitational field strength. This one is your electric field intensity or electric field strength. Now let us pick it there. So we're gonna say that the force equal to what, charge times your E, making the E the subject of the formula, which is the electric field intensity. You have E equal to F over Q from that part. So if you pick it from that point, don't forget the formula of electric force. So the formula of electric force is what? It's F equal to K Q1 Q2 over R squared. So putting all this value, replacing it here, substituting the what, the F for this one, we are going to put everything here. And we are going to put everything that is F here, we are going to replace it with this what, this F. So we're gonna say E equal to everything there, KQ1 over KQ1 Q2 over R squared, everything over what, over this Q. I hope you understand. So everything over this was this Q. So now from that part now we have E equal to K Q1 Q2 over R squared. Here now this is over 1 automatically. This is over 1. So when you bring this division to this part, we are going to have it to be what, multiply by what, 1 over Q. So here now your Q, one of your Q is going to cancel this one of this Q. So we are going to say E equal to K Q1 over what, R squared. There's no point in putting K Q1 there because the Q here is just what, 1. So there's no point in putting 1, 2. Unless there's 2, you don't need what, 1. So we're going to say electric field intensity. I don't know, maybe you can see it from here. So electric field intensity equal to what, KQ over what, over R squared. So you can see now the difference between electric field intensity and your electric force is just your number of what, your number of charges. In electric field we are dealing with what, 1 charges. In electric force we are dealing with what, the 2 charges. I hope you understand. So that's just different. And don't forget the value of the K. The K is what, 9 times 10 to what, 9 meter square per what, per Coulomb square. So that's what electric field intensity. So there's nothing new, there's no new thing there, just the formula. So I will add this to it now before I proceed. The thing is that this video will just entails just giving you the definition of all these terms in electrostatics. Then there is going to be another video that will deal with solving a lot of questions from Coulomb's laws to electric force to electric field intensity to electric potential, everything. We are going to be solving questions on all those aspects. But in this video, we are going to explain every important part of what, of electricity. Let us continue from this part. Electric potential. So this is going to be the last part of this, like the introduction to this electricity. So talking about the Coulomb's law, which talk about the force. Then the next one is what, electric field intensity. We have explained that. The last one is going to be electric potential. That's what I'm going to pick. After the electric potential, the next video is going to be on questions solving, and we are still going to, there's still going to be a video on the old capacitors, because they are part of electrostatics. So now let's continue from electric potential. So we have electric potential V to be equal to KQ over R. KQ over what, R. So before I move on, don't forget that F is what, Q1 Q2 over R squared. E, electric field intensity equal to what, K Q over what, R squared. If you notice one trend there, it is that the first force, the first one, which is the force, electric force, has both Q1 and what, and Q2, and the R is what, R is 2, that is R squared. If you check the next one, there's only 1 Q and 2 R. If you check the last one, which is what, electric potential, is just what, 1 Q and what, and 1 R. That is the formula. So that is the formula of what, of the electric what, of this electric potential. So I'm just dealing with the major calculation aspect of what, of this electrostatics, because the basic explanation, I don't think it is not very common with them asking you what is the electric potential, what is electric potential, all those kind. So electric potential is just like the work done to bring a unit positive charge from infinity. I hope you understand. So that is the definition of electric potential. So this is the formula and this is the formula for electric force, this is the formula for electric potential, this is the formula for electric field intensity. Now, continue from here. We now say the formula for electric potential is what is V equal to KQ over R. And we also say it is what V equal to electric field strength and your R. So how do I know that this formula is correct? Look at it now. If you say V equal to electric field intensity is what? Is KQ over R square multiplied by what? R. Use this one. So 1 R cancel 1 R. So we're gonna say V equal to KQ over what? Over R. So this one is just like what? Just like this one. So it is correct. The formula is what? Formula is correct. So that is for what? Electric potential. So you can say electric field intensity equal to electric potential over the distance R, or you can also be in form of E equal to V over what? Over D. I hope you understand. It's still the same thing. We are still talking about the distance there. So that is all on what electrostatics. That is the major thing I want to talk. So the next video is still going to be on solving questions on electric force, solving questions on electric field intensity, and the last one, which is what? Electric potential. So after these three, we are going to be solving. We are going to move into the next part, which is capacitance, capacitor. But for now, we are going to stop here. So that is everything on electrostatics. So we have dealt with the Coulomb's law, which deals with the electric force, the electric field intensity, and the electric potential. So that is everything. Thank you for watching. Don't forget to like and subscribe to the channel. Thank you.